Hello. In this video we're going to be doing some graphing. You have a symbolic example here, or rather we're probably more used to calling it an equation, 3x minus 5y equals 15. It's called symbolic just because it uses these symbols x and y in place of some unknown or changing numbers. And what we're going to do is we're going to convert this equation into a numeric form, namely by making a table of values. Then we're going to use that in order to graph. So I have a table of values here ranging from inputs of -4 all the way to +4. And so let's go ahead and start plugging these numbers in and seeing what we get. Let's begin with -4. So we'll put 3 times -4 minus 5y equals 15. So we end up with -12 minus 5y equals 15, or -5y is equal to 27. So y is 27 divided by -5. 5 goes into 27 5 times with 2 left over, so we come up with -5 and 2/5. Alright, onward and upward. Let's try -3. 3 times -3 minus 5y equals 15. -9 minus 5y equals 15. -5y then is equal to 24. And so when we divide by -5, 24 over -5, 5 goes into 24 4 times with 4 left over, so -3 got me -4 and 4/5. Let's keep it going. Let's do 2. So 3 times -2 minus 5y is equal to 15. -6 minus 5y is equal to 15. -5y then would be equal to 21. So -5y. So y is just going to be 21 over -5. And 5 goes into 21 again 4 times, this time with 1 left over. Let's plug in -1. 3 times -1 minus 5y equals 15. So -3 minus 5y is equal to 15. And we move the 3 over. -5y is equal to 18. So y would be -18/5. 5 goes into 18 3 times with 3 left over. So -3 and 3/5. 0 is easy. 3 times 0 minus 5y is equal to 15. 3 times 0 is nothing. So y ends up being -3. And if you sort of notice our pattern, each time we're just losing 3/5 from our number. From -5 and 2/5, we actually go up by 3/5 to -4 and 4/5. We go up 3/5 to -4 and 1/5. We go up 3/5 to -3 and 3/5. We go up 3/5 to -3. So let's keep that going. So we'll have -2 and 2/5, then -1 and 4/5. Then we have -1 and 1/5. And then we have, I guess it should be -3/5. Alright, so there's our entire set from -4 to 4. We put these points on here. So -4 and -5 and 2/3 is roughly there. And we'll go from there. So we go 1 over to the right, and we're up to -4 and 4/5. We go over 1 to the right, and then we're up to -4 1/5. Over 1 to the right, -3 3/5. Then we're just at 0, -3. Over 1 up 3/5. Over 1 up 3/5. Over 1 up 3/5. Well, that should be there-ish. Right? Because we're at 3, comma, -1 1/5. Roughly there. This one should have been down more a little bit. There we go. Makes more sense. And you can see by the points here we're going to make a linear shape. It'll be a line. And so we'll just draw on our line. And I kind of missed, so let's do better. Slightly better. Anyway, so that's generally what it would look like. And we did so by converting into a numeric form and then drawing the figure. Let's look at a different one. I have the same table of values. I have a different equation that we're going to convert into a numeric and then graph. So starting with -4, we have 3 times -4 squared minus 7. And so y is equal to, well, -4 squared is 16. So 3 times 16 minus 7. 3 times 16 is 48. And so we get a result of 41. Next, y is equal to 3 times -3 squared minus 7. -3 squared is 9. 27 minus 7 results in 20. Keep it going. 3 times -2 squared minus 7. -2 squared is 4, times 3 is 12. We result in 5. 3 times -1 now squared minus 7. -1 squared is 1, times 3 is 3. We get -4. If we put 0 in, 0 squared is 0, times 3 is 0. Those are gone. We just result in -7. Let's go back up now to 1. 3 times 1 squared minus 7. Well, 1 squared is 1, times 3 is 3. We get -4. We got that before, didn't we? Right there, and I wrote the wrong thing. There we go. Sort of. Let's put the 2 in. 3 times 2 squared minus 7. 2 squared is 4, times 3 is 12. 12 minus 7 is 5. And notice that we match here and here. So any guesses as to what 3 is going to be? I have a guess. How about 20? And then the one after that is probably going to be 41. So let's graph. I can't fit -4 comma 41. I can't fit -3 comma 20. I can do -2 comma 5. It sits roughly right there. -1 comma -4. 0 comma -7. 1 -4. 2 comma 5. So we have a parabola here. And it looks sort of like that. And we are done.